This question is on differentiation. It's a basic question, so we're just covering the basics for differentiation here. Right, asking you to find the derivative of this formula. Okay, but first of all, you need to understand what differentiation is. Okay, so differentiation is just a kind of calculation that you do to find the rate of change of something. So if you think about, like, let's say a speed time graph, right? Okay, not speed time, distance versus time. Okay, the gradient, the rate of change of this graph tells you your speed, right? How much you increase from like one point in time to the next point in time. That tells you like how fast you are going. Okay, so you differentiate the distance time graph, you get speed. Okay, and if you think about it, if you differentiate speed, you're finding the rate of change of your speed, right? And that would be acceleration. Okay, so yeah, just keep that in mind. Okay, so if you were to find the rate of change of your distance time graph, I mean, you can just do your rise over run, like using this. Like, let's say this is 4 units and this is 2 units, then your gradient is just 2, right? This will be your rate of change. But let's say you have a quadratic graph, okay, and it's like y equals to x squared plus 3x plus 4, something like that. Okay, your gradient at any point on the line is going to be different. Okay, so differentiation allows you to determine your gradient mathematically. Okay, then so I'm just going to show you an example. Like, when you differentiate this, you'll get 2x plus 3. So don't worry about how I get this first, just understand that this will be the formula for my rate of change. Okay, then if I want to find the rate of change at this point, I just need to know what the value of x is. So if my value of x is 4, I just sub it in. That will be my gradient at this point. Okay, so let's go into like how exactly we differentiate. Yeah, so if we have something like x to the power of 5, right? First, when you differentiate this, okay, this is dy dx is the symbol for differentiation when you differentiate y. Okay, so yeah, first you observe the power 5, right? We're going to bring it down. So you multiply 5 times x, right? And then from the 5, we're going to subtract 1. So you get 4. Okay, so 5 times x to the power of 4 will be the differentiated form of x to the power of 5. Okay, so I give you another example. Let's say we have y equals to 3x to the power of 6, right? I'm going to bring the 6 down, so it's going to be 6 times 3, which is 18, and then reduce the power by 1. So 18 times x to the power of 5. Okay, there are some special cases where you have, like, let's say y equals to 4x, right? When you differentiate this, it's just going to be 4. Okay, why? Because if you think about it, the power is 1. Okay, you bring down the power, you're going to get 1 times 4x, and then you're going to reduce the power by 1. So it's x to the power of 0, right? And x to the power of 0 is just 1. That's why it's just 4. So whenever you see like y equals to 7x, y equals to like 1000x, it doesn't matter, right? When you differentiate, it's just going to be the coefficient. Okay, this occurs when the power is 1, right? Another special case is, like, let's say you have y equals to 5, a constant, right? Y equals to 4. What happens when you differentiate this? It's just going to be 0. Okay, why is this the case? Because you can think about, like, if y equals to 5, right, you can consider the x term as x to the power of 0, because remember, x to the power of 0 is just 1, right? So you bring down the 0, you got to take 0 times 5x, right? And that is going to be 0, because 0 times anything is 0. So same thing here, 4 times x to the power of 0, you multiply by the power, which is 0, right? You're going to get 0. Okay, so any constant, whenever you see a constant like y equals to 1/4, you differentiate, you're going to get 0. Okay, so putting all of that together, let's say you have y equals to 3x squared plus 5x plus 10. Okay, when you differentiate this, you're going to get 2 times 3 is 6, and x, you subtract 1 from the power of 2, you're going to get 6x plus 5 plus 0. So this will be your differentiated equation. Okay, so let's apply that to this question. So this question is slightly tricky. So just notice one thing, right? This square root 7 actually is a constant. So when you differentiate it, it's going to be 0. This one looks kind of weird, but you can actually rewrite it, right? So it looks easier. So let's rewrite it as 20x to the power of 5 minus 4x to the power of negative 3, right? Plus square root 7. So let's say this is our equation. It's a function of x, right? Okay, let's use y. Okay, y equals to this. Okay, so when we differentiate this, it'll be 100x, because 5 times 20 is 100, and then 5 you minus 1 is going to be 4. Okay, for this case, you're going to multiply by negative 3, right? So it's going to change this sign to positive, right? So it's plus 12x, and then you're going to subtract 1 from negative 3. Negative 3 minus 1. So it's going to be negative 4, okay? Not negative 2. And then you differentiate square root 7, it's going to be 0. Okay, so you get 100 times x to the power of 4 plus 12x to the power of negative 4, and then just change that to a fraction. Right, it's going to be 100x to the power of 4 plus 12x plus 12 over x to the power of 4. This will be the answer.